Welcome back. When we left for break, we were talking about solving linear systems. We're going to return to solving linear systems. Those are systems that contain only lines, but we're going to show a way to use matrices on our calculator to solve these systems. The first system I've chosen is x plus 7y equals 12 with 3x minus 5y equals 10. In order to solve it using a matrix, we're going to use the Gauss-Jordan reduced row echelon method of using matrices. So we first need to turn this into a matrix. It's actually an augmented matrix, and the left side of the matrix will be the coefficients of our variables. So 1 and 7 for the first equation, 3 and negative 5 for the second equation. And although your calculator will not put in a dotted line, usually there's a dotted line to show that we're augmenting with the solutions 12 and 10. Okay, and that's our matrix. Our calculator is going to need to know how many rows and how many columns. So we're going to enter in what's called the order of the matrix, the number of rows go across. So this is a 2 by 3, 2 rows, 3 columns. And then we're going to enter all those numbers in. So second function of inverse is matrix. Their names, math, and edit. The first thing we need to do is to edit in the matrix. So arrow over to edit. Currently my matrices are all empty. I'm just going to choose matrix A. First thing it's asking for is the order. It's 2 rows, enter, 3 columns, enter. Notice it sets that up on the screen for us. Now I'm going to enter those coefficients. 1, 7, 12, 3, negative 5, and 10. And in order to get out of the matrix, I do have to second quit. Otherwise, I'm sort of trapped. Now I'm going to go back to matrix and pull in some math. The math I want is reduced row echelon form. And that's way down the screen. It's like they don't want us to see it. That's row echelon form is A. For me, reduced row echelon form is B. I'm going to bring that to my screen. Then I'm going to go back to matrix and bring in matrix A by name. And I'm going to hit enter. It has returned 105011. One zero 5011. And if we turn this back into a system, it's saying 1x plus 0y equals 5, and 0x plus 1y equals 1. And if you're looking at that correctly, you're seeing that x is 5 and y is 1. So it has solved our system 5-1. For a 2-equation, 2 unknown system, a matrix is probably not what you want because it's faster to do the work yourself. But for a system like this with 3 equations and 3 unknowns, it might be faster to use a matrix. So I'm going to go to my calculator I'm going to go to second matrix, edit, and now that matrix has 3 rows and 4 columns, and I'm going to enter those in. It was 1, 2, 3, 0, with 2. Oh, let's go back. 1, 2, 3, 0. Come on, you can do it. With 2, 2, 1, 10, with 3, negative 1, negative 1, and 5. Okay, and now we're going to quit out of this. And we're going to go to Matrix, Math, and I'm going to go to B. My calculator is not wanting to behave. Reduced row echelon form. Matrix A. And it says 1, 0, 0, 2. So X is 2. 0, 1, 0, 5. So Y is 5. 0, 0, 1, negative 4. So Z is negative 4. So 2, 5, negative 4. Would be the solution to this system. Okay, so let's try another one. 1, 1, 1, 1, negative 2, 4. If there's no variable, then we're going to fill a 0 in our matrix. 3, 4. Those are our coefficients. And then 3, 5, 5. Okay. So, second matrix. It's still a 3 by 4, but now it's 1, 1, 1, 3, 1, negative 2, 4, 5, 0, 3, 4, 5. And we're going to second quit. And then we're going to go to reduced row echelon form for matrix A, which tells us that this is 1, 0.6 repeating, 0.3 repeating, 1. 1.6 repeating, 0.3 repeating, 1. So that would be our solution. Okay, one more. I'm going to put this into the calculator. Second matrix. It's still a 3 by 4, but it's now 2, 1, negative 3, 4, 4, 0, 2, 10, negative 2, 3, negative 13, negative 8. Okay, so 4, 10, negative 8, give 3, 2, negative 13. 2, 4, negative 2, 1, 0, 3. Okay, second quit. Okay, we're going to do reduced, oops, reduced row echelon form for matrix A. And what we have is not a unique solution. We have x plus 1/2 y, or I mean x plus 1/2 z equals 2.5, with y minus 4z equals negative 1, with 0 equals 0. So let's actually take a look at that. Okay, so the matrix it spit out gave us 1, 0, 0.5 with 2.5, 0, 1, negative 4 with negative 1, and 0, 0, 0, 0. Okay, so that's not the look we got for the others. What I recommend is come back and write what it's saying. X plus 0.5z equals 2.5, with y minus 4z equals negative 1, with the truth, right? Nothing, no x's, no y's, no z's equals nothing. So that's the truth. So what this is telling us is that we have truth, so we have many solutions. And remember, when we do those, we pick a variable, a new variable. And I'm going to recommend choose z to be your new variable because you can plug it in and find y, you can plug it in and find x. So let's say that z is a, then y minus 4a is negative 1. So if I add 4a to both sides, 4a minus 1 is y, and x plus 0.5a equals 2.5. So negative 0.5a plus 2.5 is x. So here are our many solutions. If by chance there had been no solution, it would look remarkably similar to this, except the last line would have something that's not true, like no x's, no y's, no z's equals 6 or 4 or 7. So be on the lookout for many solutions, right, with our truth line, or no solutions with a line that's actually a lie. Otherwise, you're going to find that your solutions all look like X and Y, number and number. Okay, good luck.